Hello. Hi. I think my session started before time, so I'm sorry I'm a little late. My name is Anurag, founder of Avail. Been in the space since 2017. Founded Polygon before this. Avail was a project that we started in Polygon back in 2020, and we spun it out in 2023. And so we've been working on that since then. So today I'm going to speak a little bit about horizontal scaling. How scaling on one chain is not really the end game, and we certainly need to be thinking about scaling via multiple chains, and that's why the horizontal scaling bit. But that's not going to happen without seamless native interop. And so that's the topic of my discussion today. So just to give you a little history, how we started off in the first place. So we built this state-of-the-art data availability focused layer, and that was the first part of the plan. We implemented something called data availability sampling, which is something that Ethereum has been wanting to do since long, and it will be in a future upgrade, maybe a few years later. But essentially, like we started with that base foundation of building out scalability through DA in general, and we've been kind of successful in doing that through KZG polynomial commitments and so on. And so last year is when we launched on mainnet. We've been slowly increasing our capacity based on verifiability. We are also switching to a new architecture, which we call the infinity block architecture. And that will go, the testnet is due in Q3. We already have a devnet that is up and running. And essentially, like that's the plan on the DA front. Just to kind of round up what's happening on mainnet, we've got like Lens that launched last week, for example, for their whole SocialFi initiative. We've got Sophon, Skate, and 50 other rollups that are launching on Avail this year. Along the way, we also built out DA precons, 250 millisecond. We call it turbo in general. So getting down to what I wanted to talk about today, right? So we've kind of solved the scalability or the throughput aspect. We will only get better at it. We will, we are changing the way we do kind of transaction submissions, commitment generation, so on and so forth, for example. But really, we already have scalable block space. Like there's just a lot of chains and a lot of block space already out there, I think. The problem or the opportunity is that it's time for expansion, and because the status quo of Web3 is really fragmented. Like if you see the rollup centric roadmap, it has resulted in this, right? Like it has resulted in hundreds of chains being launched, and each of them look their own separate islands, right? Essentially, we've solved scalability. Fees are dirt cheap. You can build an app on any of these chains, and it's it's no longer, you don't have to pay $5, $50, $100 for a transaction. And so there's a bunch of these things in general, and there's a lot of apps going there, but it's very fragmented. It's very it doesn't seem like we are scaling. We are scaling horizontally, but it's a very fragmented reality. On the other hand, there's a bunch of bridges that make it very hard to for users in general. And so typically cross-chain experiences, terrible UX in general. Like you have to lock funds here, burn them there, mint them there, for example, and so on. And so what we wanted to do after we did the whole DA scalability bit was to build in native interoperability. And what we wanted to do was, could we come up with opportunities where users could interact with any app on from any other L2 in general. So we have now a lot of rollups, a lot of chains, but can we make it easier for users to access apps across these chains? Make it horizontally scalable so that users don't have to manually select networks, select bridging, bridger token, for example, and so on. So of course, bridge is still there. How can we get to explicit bridging being eliminated, right? And so that's how we get at this whole horizontal scaling problem. And the way we kind of wanted to do this was start at the foundation of this phase with very strict security constraints. So we opted to do this via ZK proof aggregation in general. And so initially last year when we started this initiative, we did a bunch of quick progress. We kind of had aggregated proofs between the Polygon CDK and ZK sync chains, the ZK stack chains, for example. But then, we realized that, one assumption that we had was that ZK proving would progress much faster. And that's why, in general, we began on that. But midway, we also started in parallel, this T-based, approach as well. And so that's really, what we've been kind of working towards. The horizontal scaling bit is something, the next upgrade on Avail, which is basically called Nexus. You can think of this as a precursor to chain abstraction, essentially. And this is essentially, broadly how it works. Right now you have n cross n sort of connections between all these rollups, and we are building this sort of middleware where we come up with this aggregated proof that verifies execution of all of these chains. So the end goal is really one ZK proof that kind of verifies execution for all of these chains. But there is also going to be an intermediate solution that we want to bring quickly to market, which we expect to get into production or testnet in Q3. Production end of Q3, start of Q4 is what we feel in general. And so that's how we have built it. You can see the base layer, which is focused on the data availability part. We've added this light execution environment on top, which can verify most kinds of proofs. And you can build lots of apps on top of this, right? So this execution environment is a very specialized environment, only focused on verifying other ZK programs. And you can build a lot of apps. Technically, you could build any kind of app on top. We've opted to build a few interop focused apps that focus on building this native interoperability bit. And so, as I said, we started with the ZK interop app, which we've kind of internally in DevNet we already have this working for Polygon stack and ZK sync. Hopefully with Starkware coming pretty soon. But the T app that we kind of made is much faster. We'll have a much faster GTM in general because it encapsulates a lot of chains, including optimistic rollups and such in general. And these are some of the benchmarks that we are hoping to obtain to get chain messaging up and running in general. With T specifically, we've said 10 seconds here, but we are getting 4 to 8 seconds internally. And so this is, the overall architecture for the horizontal scaling piece that we are really looking at, right? Essentially, because we started with this whole data availability focused stack with data availability sampling light clients, we have this functioning LC network that we kind of put it into this sort of format. So essentially, we have this notion of a Nexus adapter, which standardizes a lot of the chain inputs that come here. So essentially, because we kind of interact with heterogeneous chains, each of them can have their own header information, their proof verification data, for example, and so on. And so what we do is basically we build adapters for each major stack. So we will build an adapter for the CDK, Polygon CDK, for the ZK Sync stack, for Starkware, for Optimism, for Arbitrum, for example. And once we've built an adapter for one of these stacks, it then becomes easy for us to kind of aggregate this inside of a verifier within Nexus. And this can be scaled to hundreds and thousands of chains. And so essentially we start off with chains in the Avail rollup ecosystem. But the beauty of this is we are not limited to that. We are now able to kind of take in data from other rollups on Ethereum, for example, and other ecosystems as well, and do the same. So essentially, what this really ends up doing is essentially we are also able to kind of do these sort of interactions across chains, right? Like, so you could do contingent execution where you're doing one action, let's say buying an NFT on one chain and doing the payment on another chain, for example. And so this is basically asynchronous cross-chain execution, but we provide this abstraction layer so that users don't really need to know a lot of this in general. And so a lot of effort has gone into kind of arriving at this sort of eventuality, but really, the overall end goal that we have is that we want to kind of instead of this whole fragmented ecosystem of 100 different chains, for example, we want to get into this more horizontally scalable set, and that is can be made possible only if we connect these chains together. And really the intention is to arrive at Amazon-like experiences, in the sense that if you look at Web 2, like let's say in Amazon, when you're buying a product on Amazon, you're really kind of making a bunch of asynchronous calls. So you basically make a checkout call on Amazon, asynchronous request goes to PayPal, to Visa, in general, and all of these give callbacks. If the payment is successful, the product is shipped, the order is confirmed, and so on. And all of this is possible in Web 2 at scale because you use the concept of asynchronicity. And essentially, the attempt is to bring that experience to Web 3 in general, right? Like, so can we kind of make it so that developers don't really have to kind of go too lower down the stack in general to kind of offer this kind of experiences. So, you could have specialized payment instances on chains. You could have, collectible infra on other chains. And I mean, I'm giving the example of OpenSea, for example, but in general, this can be applied to any sort of app. So we are close to releasing like a prototype for Avail. Like if you know, Avail is actually deployed on around 12 chains. And it's actually the same code, same protocol, for example. But they deploy it on these multiple chains because they don't want to lose out on chains, users of each chain, right? Like, but imagine that if once we have this seamless infra in general, like typically apps would just deploy on one venue or one chain, but users from across chains could access it in one click. And so that's really the kind of future that we want to build towards. In general, when we are talking to chains in our ecosystem, I think one of the one problems that chains face is, how can we kind of help bootstrap users' adoption, liquidity on their chain. And typically, there are these liquidity mining initiatives, for example, and so on, that kind of are useful for getting more and more of these users. But I think that game is going, old, for example. And so really, how can we help chain developers, app developers lower the friction of onboarding new users, new capital into the system? And so I think this is how we, want to go about it, right? Like, so, yeah, so I think I'll just keep it short. In general, I think the intention is how can we go, so we go from this, very fragmented landscape. One of the reasons why we started building out this piece right from the foundation is this requires a very foundational sort of infrastructure push. So the reason is we started with data already sampling because then we could have ordering guarantees, and now we are adding these execution guarantees on top. And on the while doing this, we realized that this could it's not only Avail rollups that will benefit from this, but really any rollups that we can kind of get hands on the ordering of the data, which is committed to, let's say, Ethereum and other blockchains, but also the execution proof, for example. And so the DevNet is like already internally live on this. We've doing the public testnet. Hopefully end of Q2, early Q3 of sort, and quickly we'll move to production because we've made some practical conscious choices. The ZK part will come eventually, but we're starting off with the TE part, and it has been like very promising till now. So yeah, I'll basically end on that note in general. Yep, thank you.